This problem is going to show you how to do problem 6 from chapter 5 in Siegel. So let me read out the problem and then we can talk about how to do it. By the way, I'll illustrate some points in, let's first do it in Excel, then I'll show you how to do it in SPSS and R as well. So consider the number of executives for all Seattle corporations with 500 or more employees. So this is the number of executives at each of these firms. Now, I think it's probably easiest just to start out in Excel. So I'm going to go over here to column D. Part A says find the average number of executives per firm. So AVG. And let's see, the average is going to be average. And then I'm going to highlight all this. So what is this? 238. I don't want to go too far. Looks like 238 through 282. And it looks like we can just say executives. And then let's see. So the answer is the typical number of executives is 10.4. Find the sample standard deviation and briefly interpret its value. So the standard deviation will be, if we want to use the sample one, STDEV, and then I think it was, well, executives. If let's go A238 through A282. And I forgot to say equals. So we got to go up here and put an equals sign in. And so the standard deviation is 7.18. I should just double check this. So I'm going to highlight it, and we should have it all highlighted. So sure enough, we do. The other thing that we might want to have is the count of these. So let's say the count equals, so the count of A238 through A282, and so we have 45 of these. So we have a standard deviation of 7.187 something or other, and there's 45 numbers, the mean is 10. So this indicates the typical deviation from the mean. This is the mean, or the center of gravity of the histogram. It's one measure of a typical value. Part C is the one that a lot of people have been having trouble with. How many corporations are there within one standard deviation of the average? How does this compare with what you'd expect from a normal distribution? So there's a couple ways that we can do this. One way is that we could compute the range of one standard deviation from the mean. So if I took, I'm going to make this a little bit smaller. If we take the mean minus one standard deviation, that puts us at about 3.2. And if we take the mean plus one standard deviation, it puts us at about 17.6. So we could simply count the number of values that are in that range. Now what would help us is if I take these numbers and if I sort them. So let's just go sort. And now we can count them. How many values are outside of this range is probably a slightly easier question. So we have one value on that end of the tail. So 3 is less than 3.2. How many values are greater than 17.58? Well, let's see. We have 1, 2, 3, 4, 5, 6 values are greater than that. So there is a total of 7 values, 6 on one tail, 1 on the other. And that means that there's 45 minus 7, or 38 values that are within one standard deviation. So if we take 38 divide by, so let's do this again, 38 divide by 45, 84% of the values are within one standard deviation of the mean. That, of course, is much more than with the empirical rule. With the empirical rule, we would expect only 2/3, or about 68, well, actually 68% of the values. So this probably is not a normal distribution. Part D, how many corporations fall within 2 standard deviations of the mean? Well, let's do 2 standard deviations here. So we're going to take the mean minus 2 times the standard deviation. and we'll take the mean plus 2 times the standard deviation. So how many values are between -4 and 24.7? Well, there are no values that fall outside it on that end. So 24.7, looks like there's 2 values on the right end. So what that means is there must be 43 values in the middle. If there's 2 values that are missing from the other end, let's just copy this down. I hit Control C. So 96% of the values. How does this compare to what you would expect for a normal distribution? The answer is we would expect 95%. So it's a little bit closer. Part E, how many corporations are within 3 standard deviations? Well, same thing. Let's go find 3 standard deviations. So x bar minus 3 times the standard deviation. And then we take x bar, the average, plus 3 times the standard deviation. And we have 1 value falling outside of that. So you'll notice there's 41. So let's go up and write that out. There are 44 values, and if we copy this down, that's about 98%. That's a little bit less. 99.7 is what we would expect under the empirical rule. Part F is draw a histogram and indicate all this. Don't try to do histograms in SPSS or in Excel. They look very bad and they're kind of hard. You need an add-in to do them. All right, so why don't we go over to SPSS. I've already copied the data over. The simplest thing to do is to go into Descriptives Explorer. We'll bring execs in, and let's go into plots, ask for histogram, hit continue, and OK. And so I would have started with a histogram in the first place. It takes a couple seconds here for SPSS to pass through it. We see that there's an outlier. There's that 41, I think is what we saw. Clearly shows up in the box plot. Now we're supposed to indicate these on the histogram, 1 standard deviation and 2 standard deviations. I would print this and do it with a ruler. Maybe there's some way to edit this graph, but it's probably hard. One more possibility. Let's just go back here for a second, and I'm going to use this for show an alternate way of doing this. So I could compute the number of standard deviations that each observation is away from the mean. So the way I do this is I'm going to take the value minus the mean. So the mean I'm going to call $238. We're going to divide by the standard deviation. So this is going to be $239. So we can say that 3 is about a little bit more than 1 standard deviation from the mean. Now I can copy this down. I'll just go double click on this. And so if we just run a frequency distribution of this, we'll know, well, probably don't want to run a complete frequency distribution, but this counts the number of standard deviations you're away from the mean for you, and we could come to the same conclusion as we did before. So that's how we would do this problem in Excel or SPSS for that matter. Actually, I'll show you one thing in SPSS. How would we get that transformation in SPSS? There's actually a way of doing it. If we go into descriptives and we go into descriptives again, let's compute descriptives of this. And if you say save standardized values, the standardized value we've not talked about yet, but that tells you the number of standard deviations an observation is away from the mean. So let's go back to the data. And so now we know how far each number is, and in terms of standard deviations. So we could count it that way as well. So that's it for problem 6. Now let's see how to do this in R. There's an object. I've typed in the numbers. I've called it exec. So I've had to type those in ahead of time. To get a histogram, if you type exec, hist exec, you get this. Actually, the last part wanted us to show some, put lines where the mean is and 1 standard deviation and all that. So there's a function called AB line, that adds a line, and I want to put some vertical lines on. And now I'm going to get very clever. Let's take the mean of exec, and then let's add a bunch of different values. So let's go 0, 1, minus 1, 2, minus 2, and 3. All right, actually I better put a C here. Don't forget the C. And then let's multiply that by the standard deviation of exec. And so I haven't tried this ahead of time. This adds these lines. So the mean is at 10 point something. Here's 1 standard deviation. Okay, 2 standard deviations doesn't even show. Then here's the 3 standard deviation line. So that's a really slick way of doing that. Now, how could we get the number of standard deviations that each point is away from the mean? Well, in R it's pretty cool. We're just going to say scale exec. And so this gives us exactly what we got in SPSS and Excel for that matter. These are the numbers of standard deviations. Now let's get kind of clever on this. If I want the number of standard deviations rounded to the nearest whole number, I'm going to add the absolute value of this. So let's take the absolute value of this, and then if I cast this as an integer, let's just see what happens. Now I know how many standard deviations each observation is away from the mean. Now I'm going to make this into a table, and I'll save the table as, I don't know, tab or something. So let's take table of this as integer absolute value scale exec. And so here's that result. We have 38 values, just as we determined earlier, that are 0 standard deviations away, 5 that are 1 or more. There's 1 that's 2 and 1 that's 4. Now I could do a C-bind of tab and then tab over 45, which is the total number of rows. And so again, there's 84 observations, 84% of the observations within 1 standard deviation. So when you round it, there's 0 standard deviations away. If you add these two, it's 95%, a little bit more than that are within 1, and then 90 whatever to get to the 3. Actually, we could do a cumulative percent if we wanted to. Let's bring that back, and if you do cum sum of tab over 45, you get the cumulative percents. And so that's what we got in Excel.